All right, welcome everybody. Let's get started. It's 9 a.m. Welcome to our sixth presentation in an ongoing series on improving your applications through valve advancements and knowledge. I'm your host, Braden Waters, VP of Sales and Marketing with CGIS. I'm joined today by three panelists, Ross Waters, Kevin Niebergall from CGIS, and Trent Runyon from DSS. Next slide, please, there. So DSS is our manufacturer of choice for highest performance knife gate valves. Located in Niles, Michigan, DSS is celebrated their 4th birthday on Monday. And although new as a brand is anything but new, the brain trust behind DSS has many years of design and manufacturing experience in making severe service knife gate valves, especially for the pulp and paper industry. CGIS is the recognized leader in the application of severe service valves. We have been in business now for over 40 years, and we got our start in the pulp and paper industry in 1980 in central BC. Next slide. Just some housekeeping. Obviously, we really enjoy the feedback and the questions that come out of these presentations. Our knowledge is improved by working with our customers, and so we encourage that. At the bottom of your screen, you'll notice that there's the chat button. We'll be monitoring that throughout the presentation, and we'll have an opportunity to answer some of the questions at the end of the presentation as well. So please feel free to ask your questions there. We'll also be polling the audience a couple times throughout the presentation, so you'll see a poll jump up on your screen. Please love to get your feedback as those questions come up. All right, today's panelists. So I mentioned Ross, Trent, and Kevin. Trent Runyon is the president of DSS Valves. Trent has over 22 years of hands-on experience designing and improving knife gate valves. And DSS actually got their first order from the pulp and paper industry. So Trent's got a lot of experience in that industry, as well as many others. Ross Waters is the current chair of CGIS and the founder of CGIS. Ross specializes in severe service applications and solutions. And like CGIS, Ross's experience early on focused on solving problems in the pulp and paper industry. With 26 years of experience for CGIS, Kevin Niebergall is one of our longtime technical sales reps. Kevin is out of our Prince George office, which is in the heart of central BC's pulp and paper industry. Kevin is our internal specialist for a number of industries, but in particular our pulp and paper guru for CGIS. So with that, I'm going to turn it over to the three speakers today. Thank you.
Thanks, Braden, and welcome everybody. We are going to take each of us a bit of this presentation and break it up. And so I'm getting the pleasure of starting. And what we want to talk about today is the 5 different types of knife gate valves that exist and are used in pulp and paper. We want to define what severe service valves are for a particular reason. Definitely going to talk about applications within pulp and paper. Then really drill down into the DSS valves itself, what makes it special. Some more experience and case studies in the pulp and paper, and then end up with some questions and answers. So we've got the title is Pulp and Paper, and what we're going to discuss today sometimes is only a pulp mill, and it depends on what type of pulping process there is. Sometimes it's only the paper mill, sometimes they're combined. We want to take a very broad-based look at all this industry. I think it's important to look at history, and just coincidentally, a couple of days ago, a friend of ours saw this ancient monument in one of the pulp mills in British Columbia called the Powell River, BC. And this was a very interesting for us, look back to a place in 1940s where the pulp mill made this valve in their own foundry without any help, carved the pattern themselves out of wood, and then made a wax mold, and then poured the metal to a very primitive knife gate valve. We've come a long way from there, which we hope to be able to show and explain as we go. So I said, first of all, there was 5 different types of knife gate valves. A lot of people are not quite sure that is how we look at the world, but it is. The first one, 1927, you'll see in a second, it was that one on the left, what I'm going to call a conventional knife gate valve, the most commonly used knife gate of all. Then the through gate was an invention that improved the ability to take more stock, more fiber. When we started to add chemicals, the idea was let's continue to protect the valve with a liner of some inert material, but the pressure retaining body would still be ductile iron, cast iron, some non-corrosion resistant material. The push-through knife gate valve got invented not for pulp and paper, but in 1960, somebody wanted a valve for the mineral business, mining business, and a slurry valve was invented. And then coincidentally, and perhaps not actually known, in the same year, 1960, the guided shear gate was created. And we have now, we'll see a progression, an evolution from these early days to what's available today. There's many brands out there that people will be aware of. Staff Joe was the inventor of that first knife gate valve back in 1927 in Sweden. They had a customer base in the pulp and paper business that wanted a valve to be able to be used in water and fiber that essentially was an inexpensive valve to build and contain the process in somewhat of a fashion. While it was then limited into the amount of fiber it could handle, somebody decided to put a through gate into a design, and it improved the ability to handle higher loads of fiber. Again, as I say, the line knife gate valve was built in the 50s, and then we came into the 1960s. And DSS, which we're going to focus on today, is the 5th generation of the 1960s patent, and in a valve that we've called a guided shear gate to differentiate it from the word knife gate valve, because ironically, of these 5 different types of valves, there's only one that actually cuts and therefore deserves the term knife, and that is the guided shear gate. The other valves, as we'll see, don't cut. They were never designed to cut. So let's look at this. That's first valve, the conventional knife gate valve, which again is the most copied knife gate on the planet. And if you're looking at any imports from low cost producing countries like China, that's what they're focusing on. They're easy to copy, it's cheap to make. The question is, does it actually do the job you want? And we're going to challenge that with an answer of no, we don't think so. But looking inside, it's a pretty simple valve. It is got a sharp tip on the gate, but it's not for cutting, it's for wedging. And if you looked at the right-hand picture of the cutaway, you'll see a wedge that's located at the 4 or 5 o'clock position and another one at the 7 o'clock position, which is the location where when you close that valve, that tapered edge of the gate connects and pushes the gate over to the seat, whether it's metal or rubber or elastomer. That's where it works. And this valve, as we'll see in a minute, has a fairly large leakage rate. So the question is that prudent to use in your applications where you're going to get bi-leakage? The first modification, as we mentioned, was the through gate. This is really a hole in a plate of steel that carries the fiber with it. It does introduce a second packing gland, so now you've got a much bigger, heavier valve and more costly. But it was an invention to go to the higher density stocks that are available in different pulping applications. The through gate doesn't have a sharp gate tip, it just carries the product with it. The line valve, a good idea if you're trying to continue to reduce the cost of the product, because the liner itself can be just a thin piece of Teflon. In this case, we're looking at a butyl rubber valve that came out of the mining industry. But the body in these line valves is not meant to withstand the corrosive. It's protected by that liner. The problem that we see is that the packing gland is still a conventional packing gland, and the corrosive material often gets out and leaks on the outside of the body. But this particular line valve, and here we got one that's from the mining industry, as the best picture we can see, it's a urethane liner and protected the carbon steel or ductile iron body. The push-through knife gate valve, as I mentioned, was the first mining valve. It's been misapplied in many places because people think it's a good knife gate valve. It's not a knife gate valve. Its gate is got a sharp tip, not to cut, but to divide those 2 sleeves. It works very well in high solids concentrations that are neutral pH, but limited in number of cycles and limited in pressure, because the higher the pressure, the thicker the gate, the more stress on the elastomers, and eventually they don't seal again. And I'm going to go back again to see this picture on the right. That valve is open and it's free discharging. Unfortunately, that free discharge you're seeing there is acidic. It's about 130 degrees Fahrenheit, pH 1, and it's on the 4th floor of a building that's pouring down a rain of acid. Not where I would want to be underneath. The one that we're going to really focus on is this guided shear gate design that was first invented in 1960. It's very different. it comes with an idea that it should not leak, zero leakage, bi-directional, equally tight on both angles of flow or directions of flow, and no fugitive emissions as well. So a very, very different valve. In 2016, through a series of events that happened with different valve companies being bought and sold, DSS decided to get into the business themselves and design a better version. And now we've got a valve that has gone way beyond what that original knife gate valve was designed for, which was 150 PSI, to now class 1500, 250 bar, that's 3,700 PSI. You're not going to see that valve needed in some of the, or any of the pulp and paper applications to date, but we're wondering in the future, are there advantages to improving or changing some of the processing that's going to be done with using higher pressure valves? We have a valve that can do it. Right now, all that marketing is being done in the mining industry and some chemical industry. So we've got a valve.
Hey, Ross, sorry to interrupt. Did you want to launch that poll right about now?
Sure. I mean, yes, we would love to hear from anybody who's in the business of designing processes or new designs within pulp and paper. Is there an opportunity to have a more efficient, lower footprint design for pulping, for whatever, by increasing the pressure in the systems? We've got a valve that can handle it. This valve is designed for high solids applications, but it also seals very tightly on clear fluids. So it can be used on basically any application with a limit of temperature of 315 Celsius. It's about 600 degrees Fahrenheit. Quite an open ability to handle just about anything that's coming down and deal with the things that we're going to see later on that plague other valve designs, scales and solids that precipitate out. So here, if you look carefully, I'm going to leave some of the details to Trent, who's going to go through this in a lot more detail, is our basic design. It's an actual guillotine cutting machine with a primary seat and a secondary metal seat, which also protects it from over travel. Say generation 5 today. So I'm going to talk though a little bit about the more generic type of things called valves and higher performance valves. For many years, I've been wondering, how do I communicate what I know better than I have communicated? And so I'm going to start with the real basics. For me, all valves, all types of valves, only do two things. They either isolate or they control. For this presentation, we're going to focus on isolation, although I can tell you we have developed some very specific control applications using the DSS platform. But for us right now, we're going to focus continuously on isolation. So as a person who wants clarity and objectivity, I got challenged a few years ago to define severe service. Again, that word severe is subjective. It doesn't have any real meaning until we can put some numbers to it or something. And I wrote a paper in 2014 defining what I thought the thresholds were. And then in 2015, as a member of Manufacturer Standardization Society, I went to them and said, look, the industry would be better if we agreed on how to define the service requirements of valves. So they accepted this as a journey, and we formed a task force, which I had the pleasure of being the chair for a number of years. I'm giving a presentation. Sorry. And originally it was called defining severe service valves. Now it's certainly morphed since then. One thing you should know about MSS, it's a membership-driven agency. All the members who are there have a right to vote on any new work, and we have to have 100% agreement. And so over the years, since this has been going on, and we're in the 6th year, it's not published yet, we've had a lot of arguments and debate on what we should be actually achieving. And so it changed from just saying what a severe service valve is to all categories of valves by their severity of the service conditions. So just a little bit about MSS. It's been around for nearly 100 years. It develops a lot of standard practices, which are documents that are meant to improve the lives of users of valves fittings, pipes. What I started with was a fundamental division of the severity of the services by saying there are some valves that are in applications that are very challenging, they're severe services. I originally had commodity valves for the low-end valves, and then general purpose valves for the middle. But the reality was there was a number of manufacturers who didn't like that knowledge that they might be in the commodity valve business. And so we agreed to rename them general purpose and then fit for purpose. So there are three different categories. And all of these three different categories, there is a different way of looking at what their criticality is, what their importance is. And so if you look at the lower valves, lower importance valves, I'm going to say, that if you have a failure, what's the consequence? Well, it's much less consequential, so less serious. What is the most important part about this is probably the cost to buy, not the cost to own. You're not likely to repair it. You're going to probably find it in stock, so it's readily available, and it's going to be used in those areas where your process is not that important to you. In the middle category, they're more important. It may be that you do repair them or replace them. The availability is probably more likely to be stocked as well, but you may have to get some made to order ones. The purchase price is going to tend to go up a little bit from the beginning and have a bit more value. And you still can get these, but without having to really identify all of the components that we know are important for severe service. The severe service valve, though, to me is an asset. You're going to want it to be the right valve for the application, and it to be cost effective to repair instead of replace. It's likely to be available only from specialist companies, so you may have to plan on having it made for you. The purchase price is going to be higher because it needs to stay in service and do the job longer, where the cost of ownership is most important. And for this, we need a lot more data. The data that we want, anybody who's applying the valves, is going to be a much better story of what the valve is required to do. So as I mentioned before, an isolation valve is one that has a job to isolate a process. What I've learned over the years is there's actually 4 different positions that you have to think about when you're selecting valves, and particularly for severe service. That is normally open or normally closed. They're equivalent, but not the same. And then the 2 dynamic phases of an isolation valve when you move from an open to a closed position. Those are changing dynamics. Without knowing that expectancy in the life of a valve, it's really challenging to pick the right one. And as these services get more challenging, the more important it is to know that. We tried to find a data sheet in a pulp and paper application that would demonstrate this. We couldn't, so I'm using one from a mining application. But this story is one of learning, and it's an oil sands company that had a lot of pain by using valves in a high pressure slurry of large diameter solids. They had rocks going down this pipeline at around 15 feet per second, the size of my fist, also with sand and everything else. And they quickly blew out valves, and they didn't really know what was the best way of looking at it. And we told them, look, we needed to understand how often this valve was going to cycle. So in the year 2000, we saw for the first time the frequency of operation once per week. That gave us a lot more information of how to protect the valve, which was a knife gate valve in those days, from getting damaged in a very short period of time. Now, if you note too on the performance requirements, the company made a statement. They wanted FCI class what? There is no bubble tight class in FCI. It's only class 5, 6 are the tight shutoff classes, but they allow leakage. So here we were handcuffed. They wanted something that wasn't available in the way they described it. Here's another example of a nice wish. I want a 0 leakage bi-directional valve. But the challenge that we made to the person asking for it is, how are you going to determine that? What's your test? If you use API 598, the most common test, you can get 0 leakage if you use an elastomer seal. A metal seated valve has an allowable leakage rate, as does the original knife gate valve spec, which we're going to talk about in more detail a little bit later. So what are we challenged with? In the early days of the standards, the MSS SP81, which today is version 2017, it was created in 1975, the first knife gate valve specification. Originally only up to 24-inch valves and originally only for stainless steel knife gate valves, bonnetless. They had a leakage rate of 40 cc's per inch of diameter per minute, and that is if you provided the valve with 40 psi differential. Now, if you have a tank 10 meters high, 33 feet high, full of stock, you don't have that differential pressure. So if you had a valve on the bottom of that tank, you don't have 40 psi differential. If it's a 24-inch valve, that's leaking a lot. Is that what you want to have as your isolation? I don't think so. TAPI, the Technical Association of the Pulp and Paper Industry, opted for another standard, very basic. It didn't really demand much of the valve other than the face-to-face, which is really the only standard item there that one could use on, but it had the same leakage rate. So again, a pretty poor standard in my opinion. After having witnessed a lot of failures, a couple of us went to MSS and asked them to write a better spec, and it did. We came out with SP135. It's currently at 2016 version and very currently will be republished in 2020 with a couple of changes, I think imminently. And this gave us a much better handle. We are now up to class 600, which again is beyond most pulp and paper requirements, but it also makes a statement, a requirement that the valve has to be zero leakage if it's elastomer seated or rubber seated. So you have a much higher performance device.
Hey Ross, I'm just going to end the poll right about now. It's a good time to kind of interject. So here's the results for everyone. Not sure if you can see that, Ross.
Yeah.
Basically, the question was, could there be an advantage to increasing process pressure in pulp and paper? 32% of the viewers voted yes, 3% voted no, and the rest were not sure.
So I think I'd like to challenge people. Let's see what we can do. Can we build a smaller footprint of a pulp mill design in the future, even as an add-on, a brownfield extension? There's got to be ways that we can make the pulp and paper business more efficient by looking at an ability to provide maybe faster pulping times. But going back to the historical selection here in Canada, where I am, we were basically handcuffed to even today, because the specs that on the left-hand side, you see one of the famous pulp and paper designers, H.A. Simons, who later got bought by Agra, who got bought by Amic, who got bought by Wood, but using standards that in this case, this one is from the 1980s, but it was already around in the 1950s and 60s, and it's still used. So that technology is very ancient, and certainly in this case, this was an SP81 valve that had that huge leakage rate. One of the pulp mills in Canada that we've had for many years, Caribou Pulp, they just took a version of it and made an internal valve standard that really says the same thing. It doesn't have a very high performance requirement. What we see though then is that mills that continue to use these old standards are handcuffed. They are buying items that will prevent them from having the best isolation of their process. It's very challenging to make a conventional knife gate valve packing gland work. You're going to need to either continuously maintain it or put up with its leakage. How do those valves deal with scale? Now this is scale, fortunately you couldn't get a picture of the green liquor or heavy black or some other scaling liquor in the pulp and paper business for this presentation. This is a mineral process, but it's the same idea. How do you close a valve on that kind of scale? We can do it today with DSS. We designed the valve to cut through the worst scales that we could see. This valve is kind of interesting in my mind. It's a 2004 photograph of a 10-inch class 300 knife gate valve with a 22-inch bore cylinder. We calculated the horsepower necessary to close that valve against a 1 inch of scale that could precipitate out in the time it took to be able to take control of the process. So I'm going to now turn this over to Kevin, our senior salesman from the middle of Prince George. He has got a lot of experience in the day-to-day life in the pulp business. So Kevin, take it away.
Thank you, Ross. Talking about pulp and paper, there's a wide range of pulping processes that we'll find across the world. We'll focus on the the processing of wood chips into a pulp product or a paper product, but it's used in cotton. It's used in recycled newsprint that we refer to here. So there's many other pulping processes, but for our conversation here, we'll talk about the pulp and paper industry based out of the forestry world. When we look at the pulp and paper processes, we have chemical processes and we have mechanical separation. And underneath the chemical separation, there's essentially two common processes that were developed back in the late 1800s and early 1900s that has continually evolved as we've learned more and we've become more efficient. The Kraft, which is a German word meaning strong, it's used to produce strong paper products. The sulfite process, still in existence, but we're typically seeing less than 10% of the mills around the world using the sulfite. And really, when you're talking about the two processes, they achieve this similar results. But in the sulfite world, we're going to be talking about red liquor, which is the outcome of using the cooking chemical inside the digester. Whereas in Kraft processes, we're going to, or sulfate process to be more specific, we'll be seeing black liquor as the outcome of the cooking chemical collecting inorganics from the digesting process. Chemical separation processes are very attractive to us with the guided shear gate design. They definitely produce more severe service type applications to utilize the DSS product or guided shear gate product in service. Whereas mechanical separation, TMP, CTMP, those acronyms are thermomechanical pulp or chemi-thermomechanical pulp, where thermomechanical pulp will produce brown stock. CTMP will produce a bleach stock or a white stock. And that's something to note about chemical separation that we'll get into a little bit further. They do also have a bleaching process to make white pulp or paper or brown stock or brown paper. And then we have recycling and repulping mills where we are taking used paper, cardboard, reprocessing it to recycle and create a new product. The paper world, there's fine paper, tissue paper, newsprint, cardboard. There's a variety of different paper products that are produced by mills, and as a result, they will have slightly different processes to meet the quality requirements of their client base. Next slide. So this is the chemical breakdown. I'm not a chemist, but we have here what we're looking at is the polymerization of the lignin. So in the digesting process, in a chemical separation facility, we are mixing, we're initially heating it. We have an impregnation vessel that is injecting steam into the vessel. We're adding some white liquor or sodium hydroxide. That is now liquefying essentially the lignin, the glue that holds the fiber together. And from there, it'll move into the digester where there's really a 3-zone in that upper vessel, in the vertical vessel. We have 3 zones. There's the upper, lower, and middle. And the sodium hydroxide or white liquor is throwing through there. They're also injecting heat via steam, and that is continuing to break it down. It's really softening the wood chip that is come from the wood yard, so that when it is blown into the blow tank, it will essentially just disintegrate. It will just explode into a fibrous form, but it's not fine enough yet to produce pulp. So as a result, it will now flow through the fiber line where they screen, they remove knots or shives. Shives are just basically like slivers of wood that haven't properly broken down. So the screening process will remove that. And through there, we have some applications where a guided shear gate valve performs very, very well versus conventional designs and also other type of valve products. As we go through the washing process, the weak black liquor, which is the lignin and the spent chemical, is being filtered or removed. That can be done through a vacuum process, filtering processes, and that's extracted so that we are now increasing the density or the percentage of solids in the flow stream. And it's multiple cycles. You could see 3, you might see 5, you might see 6. It all depends on the size of the mill and the end product that they're producing. As it flows through washing, we're still screening. We're still looking to remove any of the bad items, whether they're shivs or knots that have traveled through previous screening levels. And from there, the brown stock may go straight to the pulp or the paper machine, or it can go through a bleach plant where we're adding, we're either using a process of O2 oxygen delignification, or maybe using chlorine dioxide, hydrogen peroxide to really brighten the pulp stock so that's white, so that for our fine writing paper or for back in the day when we still used photo paper for pictures and such. It's just the refining stage before they print or before they process it in the machine room. Coming off the washing stage, as we remove some of that black liquor, we're moving into the recovery cycle, and we're flowing that weak black liquor through evaporators, multiple effect evaporators, or MEE. And again, you can have various number of stages for that, but we're converting the weak black liquor to strong black liquor, and finally into heavy black liquor, which is all defined by the amount of solids that's present in the flow or in the media. And it is then burned inside a recovery boiler. And from the recovery boiler, we burn out all the organics. There's a heating value, so they're producing steam through the recovery boiler for the rest of the plant and rest of the process. But as it passes through the recovery boiler, it drops to the bottom as a liquid, which is smelt, and it has a variety of different solids in it that didn't burn, and it tends to create this green looking liquid, so we have green liquor. And so that smelt is taken to a dissolving tank. From the green liquor stage, we'll start adding lime to it, and that lime creates a exothermic reaction, generates a lot of heat, but we're converting the green liquor into white liquor. And the lime, the calcium carbonate, is assisting that, is the catalyst to make that occur. So with this chemical process and the ability to recover or recausticize the chemicals, this was a huge evolution for pulp mills in the early 1900s to increase their feasibility. As we know, better now than we did then, that pulp and paper operates on narrow margins. So any efficiencies that they can find are very important to the feasibility and longevity of pulp and paper processes. Next slide, yeah. So the mechanical process, you have thermomechanical pulp, you have disc refiners, various types of mechanical means of separating the wood fibers. And that will, from the wood room, the chips will come in, they still steam and soften the chip before it goes into your disc refiners. And then it'll go into a blow cyclone. They don't have the same pressures that the chemical or the craft mills do. So referring back to that process, in the blow tank, we're looking at class 300 to class 150, and we're moving at high velocities to create that separation. In mechanical processes, we may see the blow cyclones where they're blowing into and they're creating the turbulence to break that fiber down. It'll go through additional washing stages and then move on to the pulp or paper machine. So when we initially looked at guided shear gate valves when they were released in the early 80s and then into the 90s, as generations 2, 3, and 4 developed, we developed a ASME pressure rated guided shear gate valve or knife gate valve, which meant that we can look at other applications outside of the conventional knife gate valve world. In a typical pulp mill, if there's 100 conventional knife gate valves, with a guided shear gate valve, we can displace likely 40 to 60% of those for varying reasons. But now we can also look at ball valves, wedge gate valves, plug valves, where no one would have considered using a conventional knife gate valve, because conventional knife gate valves, depending on size, the maximum pressure rating that we typically see is 150 cold working pressure. In some of these applications, we're working at temperatures and we have higher pressures. And when the valves get larger, 20-inch, 24-inch, those conventional knife gate valves may only be rated to 90 or 60 PSI cold working pressure. But in a guided shear gate valve, we have an ASME pressure rated valve. So at class 150 and 316 stainless steel, we're good to 265 PSI at 100 degrees Fahrenheit. We can go to class 300, where we're rated to 720 PSI at 100 degrees Fahrenheit. We can now take advantage of the design and displace conventional valves that are much larger, and we can provide a cost savings on acquisition and provide a far better performing valve. So digester capping valve, probably a $300,000 valve for a continuous digester. Anywhere from $250,000 to $300,000 for that valve itself. We can look at 20-inch, 24-inch class 300 guided shear gates and be a fraction of that cost, likely 50 to 60% of that acquisition cost. So some significant savings available, and still provide far better performance because we don't have any cavities. We've got a knife gate valve that cuts through, shears, as the name of it refers to, as a guided shear gate. And then in digester blow tanks, we were talking earlier before the meeting, in 1982, 1983, CJIS supplied a number of guided shear gate valves to the Canfor Northwood Pulp Mill that remain in service today. The valves have been in service for roughly 40 years. And it has led to Canfor making the DSS, their stores inventory knife gate valve. Trash extraction, rock trap, junk poop. This is where we're handling a wide range of, or wide array of material. We have solid chips, we might have rock, we might have staples, we might have metal banding in the flow media, and we need to remove that. So through that process, as on photo shows on the right, we'll have a 2-valve mechanism or a setup, and the upper valve is open, the lower valve is closed. As that chamber between the valves fills, they will cycle the top valve closed, open the bottom valve, discharge the trash or the and to a tank, or to a in some cases they're just carts, and they cart it away and they put it into landfill or into their hog fuel supply. So with the number of cycles there, we've seen valves that were lasting, conventional knife gate valves that lasted anywhere from 6 to 12 months. With a guided shear gate valve through DSS, we've been able to last 4, 5, 8 years. And the important thing to be thinking about there is how many cycles does the valve perform in a day? When we get to 400 a day, we need to have a closer look and discuss it. But up to 400 cycles a day, we can generate 5 years of life. So we can last 5 times longer, and that'll increase obviously provide a low cost of ownership in a product and increase reliability. So into the whitening or the bleaching, chlorine dioxide, O2 delignification. We're seeing class 300 valves in O2 delignification on the reactors because of the temperature and the heat, and the pressures present. Hydrogen peroxide, we're looking at titanium valves or super duplex 2205, 2507 valves to withstand the corrosiveness of the chlorine dioxide chemical. And these have to happen at heat and at certain pressures in order to be efficient and minimize the amount of usage of chlorine dioxide. This is a 36-inch titanium guided shear gate valve. Typically this is for stock tower isolation, so it's the lower valve on the stock tower. This valve was installed in 1998, I believe. It's still in service today. This replaced a through gate or a through port valve. And in talking about it, because we have a fully guided blade in a vertical piping system, as the valve opens and closes, it remains in contact with the seat. And I note that just below the crane hook at the 12 o'clock position in this photo of the valve, we have some gate modifications of to allow for media to discharge as the valve is closing. So it's self-cleaning as the valve cycles open and close for these vertical applications. Medium consistency pumps. Early days, couldn't use a knife gate valve on a medium consistency pump. These pumps will produce pressure from 180 to 210 PSI on their discharge. So the common selection was a metal seated ball valve, or some plants would put wedge gate valves. But wedge gate valves are hugely problematic because of their groove. It'll build up with stock. It'll get hard as a rock as the valve opens and closes, and that stock dewaters. So isolation of a pump eliminates, if it doesn't succeed or is not isolating properly, it can create additional downtime in order to do any type of pump repair. In a guided shear gate valve, we can shear through the solids present, we can handle the higher percentages and provide zero leakage isolation in those applications. And with a guided shear gate valve, it will provide significant cost savings over the traditional valves that have been selected. The paper process. So this is a schematic or a cross-section of what a pulp or paper machine would look like. On the far left-hand side, we have the head box, where we're basically, that's our reservoir for the stock that is being laid onto the decker. To the right, they call it a dolly roller, having flattening the stock on top of the wire mesh. And underneath, you'll have vacuums that are sucking out white water. And it'll go through number of stages and drying to create a solid end product through the calendar section. So here's a photo of a DSS guided shear gate valve on a low consistency refiner at one of the Prince George Pulp Mills. We've had these valves in service for roughly 22 years. Initially, it was all 8-inch valves, and now they've increased the volume of their head box, and these are all 12-inch now. This is a photo that is from a local pulp mill. This is a chemi washer application where we have weak black liquor. It's showing a push-through knife gate valve, and we can see the significant leakage of black liquor that's coming from the valve body and through it's a two-piece body. It's coming through the joint and also leaking from the seal area.
Okay. Ross, I don't know if you wanted to comment on that last photo. I know we had talked previously about the black liquor on that, and I didn't know if you wanted to add anything to that before I move on. You're muted, by the way.
Yeah, sorry about that. Yeah, the quick story there is that that this pulp mill got some new employees that were from the mining industry, and what the mining industry knife gate valve of choice, the push-through knife gate, was in their minds able to handle slurry. That was the key word, and liquors are seen as slurries. So a person who didn't quite understand what a black liquor slurry would be said, "Hey, I got a great slurry valve." They put this push-through in, and it's not the fault of the valve; it's the design of the valve. It was quickly unhappy situation in that mill.
So interesting. Ross and Kevin, thank you. Both of you guys have spent quite a bit of time talking about guided shear gate valves and the benefits of it compared to traditional knife gate valves and others. And so I just want to spend a little time talking about what makes DSS the best severe service knife gate valve. And one of the reasons is that DSS makes a knife gate valve that can actually cut. Not all valves can, as we saw with the illustrations earlier. Conventional valves cannot cut, lined valves cannot cut, push-through valves cannot cut, and that's because their gates are not fully guided. Encountering solids in the pipeline can cause their gates to deflect and warp and ultimately leak. So the guided shear gate design consists of two key elements that you see here: a shearing tip on the gate, and internal gate guides that guide all the way through the stroke. So kind of hard to see the gate guides here in the image, but it's in the left upper left-hand corner of the image, and it guides the gate all the way through the stroke. So from full open to full close, the gate is guided the entire way, which removes any option to deflect when solids are encountered. When it does hit solids, the shearing tip fractures the material, angles it away from the sealing surface, and enables zero leakage where the gate meets the primary seal down at the bottom there. You'll notice we have a secondary seal, and that further eliminates leakage to atmosphere, being that we have a split body design. We have a good demonstration video that shows our valve shearing rocks. We're not going to show it to you here, but if you venture over to dssvalves.com, you'll find the video, and it's pretty impressive. You'll find a lot of other videos there too that you'll find helpful. So really, everything for DSS starts with our severe service knife gate valve and the backbone behind all of it. Many of our design elements span across the entire product mix, which is the most important feature, the guided shear gate design. These design elements are incorporated in all of our valves: the double block and bleed, the M81, TIV, junk trap, round to square, square to square. All of them include all of this technology. Talk to you a little bit about M81. It's unique in that it lands between fit for purpose and severe service. So we talked a little bit earlier on about the three levels of service, and we fall in between with the M81. And basically what we did there is we pared down our severe service knife gate valve to create a lighter offering that's perfect for applications that still require bi-directional zero leakage isolation, but only up to MSS SP81 pressure specifications. M81 attacks the low pressure severe service application that don't always need our decked out severe service valve. This valve is a great option for applications such as pulp and paper that require tight isolation due to media container fibers, scale, and other dissolved solids, but only the MSS SP81 pressures. So it really is a good option for pulp and paper. You see here our transmitter isolation valve. It has the same backbone as our other product. It's just equipped with a ratchet handle for ease of operation up against the tank. It's got purge ports to flush the valve chest, dissolve the solids and scale, and assist in transmitter calibration. It also has a special transmitter flange for seamless integration. So let's talk a little bit about the problems we solve compared to other conventional knife gate valves. Pipe turbulence and erosion. All of our valves have a full round bore with protected internal guides. A couple images a few slides back that Kevin was talking about, that large valve on the stock tower. You noticed he talked about the modification to the gate guides, and that's because that valve didn't have a full round port like ours. And so those modifications were made to assist in getting the media out of the guided area, which is one of the reasons that DSS is the best in the business. We've tackled that problem and improved upon it. And so we design all of our bores to match STD pipe sizes on class 150 and XS pipe sizes on class 300. And we also offer custom bore reducers to match lined and HDPE pipe. Leakage to atmosphere is a concern for all valves. And these images compare the guided shear gate manufacturers to DSS. A key part to this style of seal is the Teflon packing, which hydraulically loads the transverse seal to maintain tension across the gate. The guided shear gate's transverse seal system is far better than any other method of packing used by any conventional knife gate valve. As you can see, Gen 2 on the left has a single scraper on the left-hand side and a thin cross-section of the transverse seal. While stroking, this can allow packing to be drawn out and the scrapers to be pulled out as well, preventing the seals from stopping fugitive emissions. Gen 3 and 4 made some improvements to this by adding an additional scraper on the left and right. However, the thin cross-section was still a problem, and scrapers pulling out was also an issue. So DSS on the Gen 5, we improved all of that. We did wider seals, deeper, thicker cross-section, bigger scrapers. All of this makes it so that we're able to allow for zero fugitive emissions, even in high cycle applications. While all guided shear gate manufacturers use a similar transverse sealing system like ours does, there is variation, and DSS is by far the best and the newest design. Because of the sealing technology, all guided shear gate valves can cycle 10 to 50 times more than other types of valves. Another key part to true isolation is that our seal all the way around the gate is mechanically retained. So you see some dimples in the machine surface there, and what that does is retains the seal all the way around the gate as it actuates. This eliminates stretching, tearing, and deformation, and again, ensuring zero leakage isolation. Pipe stress is an issue for any valve, especially split body designs like ours. So we perform finite element analysis, or FEA, on every valve size, ensuring sufficient body bolt sizes and quantities are designed. Any failure of the actuator mounting structure is viewed as a valve failure. So all of our actuator structures go through the same rigorous evaluation using FEA as well. And so you can see that kind of in the upper right-hand side, really kind of a exaggerated view of the stresses that can be put onto it with actuation. The next slide is a photo of a failed structure. DSS is on the left, and you can see a competitor's over there on the right. And this is what we want to avoid happening. Again, any type of failure in the top structure is viewed as a valve failure, even if it doesn't leak to atmosphere. Next slide. Utilizing correct manufacturing techniques throughout the process is key as well. All of our patterns are made from the best red board material, which you see there on the right. This material won't warp, crack, or deteriorate in the harsh foundry environment. We use solidification software as well to predict and correct cast defects before the castings are even poured, which is what you see over there on the left. This prevents costly and untimely setbacks at the machining level. Weld overlay is another thing that we use in a lot of different applications, and it really has a use in pulp and paper as well. It's intended to improve the wear resistance along the flow path in the seating area of the valve, and by welding a metal like chrome carbide or tungsten carbide to the base metal of the valve life can be extended dramatically. One of the areas that we do this often in pulp and paper is on the trash extractors in those extreme situations.
I think one of the most important things that we've learned over the years is to share information. And part of what CG's world has is to really understand the application and keep a track of it so that we don't have to let somebody be a guinea pig. So we're very good at sharing, and the history we've had with DSS, the team at DSS, which, you know, as we said, is more than 4 years. It's way longer than that. It's 25 that most of us have known each other. We all agree that having this information helps everybody, not only the people who are trying to sell a better solution, but the people who own mills who need to have better control of the system. So our reference list is extensive. There's at least 5,000 installations that we keep track of. The one going back that Kevin mentioned, nearly 40 years old, was very, very important to us to understand how good a valve we actually have. It's so good that we've been able to accomplish something that is very rare. It's getting an oil and gas approval, SIL 3. It's a safety integrity level. It's a prediction of failure, of how long it will take to fail. And SIL 3 for a single valve is very challenging to get. and we are within days of getting it, Trent. I
Yep.
know it's done, yes.
Yeah, within the next week we'll have it.
So we are able to do things that many other companies can only dream of. And what this does is give our clients the safety of being able to control their processes much better. We have a lot of international customers. Here's a few of them from Canada and US. Certainly, we also have mills in Vietnam, in Australia, Africa. It's a lot of different experience that we have with us that we're willing to share. We want to share. We think talking about applications and challenges will benefit everybody, including us, obviously. But we're very open with our information. I think from now, for the next few slides, you're going to see just some other examples of where we have succeeded. And I'm going to invite, I think, Kevin here to come back and explain what we're looking at.
Certainly, thanks, Ross. On the left, we have a DSS guided shear gate valve installed on the low consistency refiner at PG Pulp, flowing into their head box. And on the right, in the same area, this is a ratty screen. So this is part of the screening process to clean the pulp or keep it at a high quality. And that's a 3-inch automated valve with a pneumatic cylinder. And we initially worked on this project in the late 90s, and as said earlier, as they increased the amount of pulp that they were flowing to their paper machine, we expanded from 8-inch to 12-inch. Next slide. Did Ross freeze up?
Did we lose Ross?
I think we may have lost Ross.
Is okay.
All right.
1 second here.
Oh,
he's back.
looks like he's back.
Okay, is everybody back?
You're back, but we lost the PowerPoint.
Oh, so how do I get that back?
You need to share screen.
Okay.
Share the PowerPoint.
Yep.
Where do I do that again? On
You hover over the controls should show up.
While Ross is doing that, there's a couple of questions that's come in, so maybe we can answer those while we get this
Yep.
back. So a couple questions. Two of them are on actuation. So what's the most common way to actuate the valves? And follow-up question to that is, are electric actuators becoming more effective options?
It's okay, Ross. Don't worry about it. I'll share my screen.
Okay.
I think in the pulp and paper industry, pneumatic actuation is the most common. Electrics do play a part, but in the pulp and paper industry itself, pneumatics is definitely a far more common way to actuate the valves. Electrics do definitely serve a purpose. And
I think we have a photo coming up of one of our valves that actually did get an electric actuator in Prince George as well.
We
so
do,
we'll be able to look at that.
Yeah.
Hey, sorry guys, are you guys seeing the full screen PowerPoint?
Yep.
Okay, perfect. Next slide, or let me know.
Yep, back over to you guys.
Mine is not showing, so don't know what I'm looking at right now.
Okay. So we're now looking at, on the right is a pneumatically operated DSS guided shear gate valve. What's of interest here is that we can see the valve is in a closed position. The orange clevis or block between the two upper yoke structures is one way of determining what the position is. But with the modular top work structure that is standard on the SV1, SV3, and so on, we have limit switch ports that are drilled and tapped into the top work structure. The blade will accept a trigger. So we have a very modular design that is easy for the mill or for the customer to work with. As they've wanted to become more and more efficient, these are tied in with a 3-pin mini connector so it makes for very quick and easy adjustments or replacement as the limit switch may falter. On the left, talking about the ability to replace ball valves, wedge gate valves. This is a drain application. So we've taken a guided shear gate valve and you can see that it's directly above a sewer. And to get zero leakage isolation, we're either replacing conventional knife gate valves that don't have enough pressure to properly isolate, or we're replacing ball valves that would be typically seen in this type of application, because over time, as they build up with stock in their cavity, they cannot properly isolate. We don't have that concern in a guided shear gate design. Next slide.
I'm not controlling it, am I?
Yeah, you can move the slide. Yeah. So
Sam's controlling it.
Good.
You're good, Ross.
yeah, so this is a wider view of the Ratty screen at PG Pulp. We have a early generation guided shear gate on the left, and on the right in the center, we have the DSS guided shear gate. And both are pneumatically operated. Next slide.
I can talk a little bit about this one.
Sure.
This is at a mill in Alabama, and so the interesting thing on this is that we see often, I'm sure Ross and Kevin could chime in a little bit on this, is that we see mills that want to stick to the spec, and the spec may call for 317 material. Wherein oftentimes we're seeing, better materials for applications. And so this was a customer that was adamant about keeping 317 in there. And we did a presentation, talked about duplex and super duplex and titanium grade 2 in their bleach process. And so they agreed to try some of our valves. So we said, even if you stick with 317, we guarantee that our valve is going to last longer than the incumbent conventional knife gate valve, because we don't have the pocket at the bottom where the gate meets the bodies for the bleach to sit and corrode away the material. And so they installed these, as you can see, in September of 2019. And so we were just down there last month where they pulled the valves out and wanted to tear them apart and do an inspection to see if our valves truly did hold up as we said they would, and they did. So they saw improved performance out of the 317, and then the titanium valve, which I believe is in the next slide, Sam. Go ahead. Yep, that's titanium DSS in the same application. So pulled that apart, inspected it, had their whole crew there, and we're very pleased with the results after 1 year installation. So it really highlights that sometimes you have a battle with some of the staff at the site just because they want to stick to the spec, but there are better options out there to improve the life of the valve.
And if I might, on that last photo, you could see that the valve is installed in a horizontal piping system. The hand wheel is out at the 9 o'clock or 3 o'clock position. With that transverse seal design, it allows us to put the valve in many different orientations. Whereas in a conventional knife gate valve design, because of the packing and the seat joint, that is 99% going to be leaking majority of the time out through the chest area. But with the transverse seal, we isolated all 8 surfaces, so the 4 corners, the 4 sides, or the 2 sides and the face, so we can install them in a variety of positions.
Yep. This is a trash extractor cyclone at a mill in Wisconsin. Just kind of highlights the 4 valve setup for that. And this is really an opportunity for DSS on our junk trap valve. Again, we do round to square, square to square, whatever the arrangement is that particular facility needs. This is the same issue that we just talked about on the 317 and the titanium application in Alabama. Just some more installation photos there. Next slide. So this is the one that I talked about that was getting outfitted with an electric actuator. So we do make through gate valves, or O ports as these are often called. This is a titanium 18-inch. The customer Kevin, you could probably talk a little more about, they were adamant about that type of a valve design. Even though we had 18-inch titanium sitting on the shelf and could do a quick delivery, they didn't want to get away from this style of valve. And so because we are an engineered company, we offer a lot of different solutions. And so we created this, which is better than the incumbent through-gate valve that they had in there. And then we shipped it up to Canada, and CGIS installed the electric actuator.
Yeah, and the electric actuators are standard on their D1 and D2 towers for the chlorination stage or the bleaching stage. And my opinion is that a through port was not required. I mean, one of the main purposes or design philosophies around through gates was to support the blade as it opened and closed and keep it in contact with a seat in vertical piping or vertical tank bottom applications. We already have that with the standard guided shear gate design in the SV1 from DSS. But as Trent alluded to, the team leader was very adamant and had greater trust in a through port. So we were able to accommodate that request. And what I will say is our through port design is far superior than conventional through ports because of our transverse seal in the upper and lower sections of that valve body.
Yep, uses the same technology as we use on our other product.
Yep.
This is a cutaway view of the M81 that I talked about earlier. So it just really kind of dissects the valve and shows you that it's very similar to our standard offering. The difference is we don't have the extra transverse seal or the atmospheric seal. Cuts a little bit of the cost out. We've shaved off some of the weight, and the reason is that with this type of valve, it doesn't need to hold the pressures that you'd see with our severe service valve. So this is a great option for Pulp Mills where you want a better valve. Like I said, this really falls in between fit for purpose and severe service, and it's a good solution there. We make this in 2-inch up through 12-inch in hand wheel, as you see, and then the next slide shows an automated version of the M81. So this is equipped with a pneumatic cylinder, and then you can see some of the accessories that were put on there by one of our distributors in the Western states. Did that in-house as well, and they've got limit switches or proc switches mounted through the yoke structure and put on some extra stuff there. So there are ways to automate the M81. While we don't have as many options available on that, there are some that make it a good fit for pulp and paper. Next slide. Again, we talked about the junk trap, round to square, square to square. You saw that image a little bit earlier as Kevin talked about it. So just kind of a breakdown of where that's used. And one other thing that we didn't really talk a whole lot about is vortex breakers can be included in the system. So the next slide, you'll see an image of a DSS vortex breaker to eliminate what you see happening on the right. Do you have anything to add to that, Kevin or Ross?
No, I think that one on the right, though, is very, very telling. This is what a vortex does. It swirls, and it, in this case, it eroded a beautiful pattern on a 316 stainless steel gate. So it also kind of brings up that 316 isn't that hard. So when you want to have more resistance to abrasion and erosion, the two forces that are in effect here, you may want to go to a harder gate to prevent that. But the vortex breaker is a simple way of stopping that destruction on the right.
Hey Russ,
Yes.
I think your camera got adjusted there. I'm not sure.
Sorry. How's that? Better?
There you go. Yeah. Okay.
Yep.
We'll see this on the cyclone cleaners that are commonplace in the pulp and paper industry. So if you're talking with a client or if you have these cyclone type cleaners, this is going to be prevalent. We can also see this in going back to when Trent talked about chrome carbide overlay and where you might use it. Inlet to centrifugal pumps. If there is not a lot of space between the valve and the housing of the pump itself, there's turbulence, there's rotation occurring inside that valve. And while we might not think that pulp is very erosive, it absolutely is. When you move it at certain velocities and churn it, it will do what we're seeing to that blade in 316 stainless steel. So having a harder a stellite tip, having chrome carbide overlay, the vortex breaker we're going to protect the valve so that we get longer service life.
Yeah. So I think we've run over a little bit. We got 2 more slides to go. If you push the next one, Sam, to show the outlet square, and then go to slide number 78, which is lessons learned. Are we there?
Yeah, can you see it, Russ? Lessons learned?
I can't, but I got my own copy. So
okay, it's up.
Okay, so there's things that we have learned over the years that we want to share and we want to bring up into the public. Right now, for sure, the more we know about an application, the more we can help, especially when things are challenging. There isn't one valve that does everything. That's, there are no bad valves for sure, but there's no perfect valve. Despite the fact that DSS is one of the best designs I've ever seen, it isn't perfect. Even though we can handle a huge amount of applications, there's always going to be some that don't fit a linear valve like a knife gate valve. But we do also want to know things, simple things. Normal starting position. Am I an open? Is my life mostly open or is it mostly closed? How many times do I cycle? What is the minimum performance that you want from that isolation valve? We've had in my lifetime a misunderstanding about what the performance of isolation valves are. I've heard things like tight shutoff, zero leakage, bubble tight, all these things. They sound good, but are they meaningful? And how do you actually determine what you're seeing? Some applications require tighter shutoff, and the perfect tight shutoff to me is zero leakage. This is what DSS produces. When it's closed, there is zero transfer of upstream to downstream. And it can stay that way, provided we do the right job and arm it with the right bill of materials, the right pressure classes, and understand what could happen to it in its place. It can be used in a lot of places where other knife gate valves could never do it. And so we are challenging for a wider range of replacements where the cost of the DSS, which we're not pretending it's the lowest cost knife gate valve, it isn't, because it has way more options than the basic conventional one, but it's competitive. And when we're against other technologies like ball valves, then we are very competitive and less costly to purchase, and therefore give that really value the cost to own. You do want to have a higher safety margin in sizing. I see data sheets that say that the air supply system is 60 to 90 PSI. So what would you do if you were putting this in a severe surface application? Would you size on the 90 PSI delivery or the 60? As a prudent, careful, conservative person, I'm going to challenge you to say on applications that are challenging, use the 60. It may result in a bigger actuator, which may be more costly, but when you need it to close for a critical application and you don't have that 90 PSI, you only got the 60, you can be sure that you can close it on that. So you put it towards the idea, what is the criticality of having failure? I think too that the beautiful thing about the DSS is its versatility. As I mentioned before, and we've all said, it's not only the best knife gate valve in the world, it's the best valve for challenging applications in its pressure and temperature range. And the temperature is, as I say, pretty good, up to 600. In summary, we want to deliver something that has a minimum performance that is really worth what you're paying for. Your corrosion allowance for the trims, that is the parts of our valve that are required to stay pristine. The gate need to be better than the pipe that are in, because the corrosion allowance for pipe is more generous. We don't want to corrode that gate and have holes in it so it can't seal. The actuation has got to be sized properly. We're very good at understanding what that is. And over the years, we developed a sizing program that we're happy to share that identifies the inherent thrust that's required to open or close a DSS when it's new, and adds in a factor from the media. So that's shareable. There's 5 different platforms. Actually, I think we're going to 7 eventually, but the 5th at the moment is high scaling applications that you'd expect to find in heavy scales in liquors. We're now saying that there could be 2 or even 3 of those, depending on how much scale is precipitated out. We do understand that what it costs to buy something is very important, but you really need to also understand that there is a cost of owning that can be balanced and should be balanced, and there is a perfect balance at some point. Experience certainly counts. We've done this before. There is very few applications that we haven't tried. Of course, in the early days, we had some failures, but failures teach you what not to do the next time. My most famous one that I had was I sold some valves to Weyerhaeuser Pulp Mill in Alberta on a liquor application, and they worked perfectly for the 7 months that they installed them, until I got a phone call saying all of these valves had failed. And I went, I can't imagine why. They had Viton seals in them. What happened was they had an annual shutdown. In the annual shutdown, they steam cleaned the pipes where these valves were. The valves had open gates. Steam and live steam and Viton don't like each other. The Viton got damaged, and when they went back to normal operation, not with steam, but in the black liquor, there was no seal left, and so we failed. And so what that taught me was ask another question. How do you clean your lines? Really, you got to think about too where we are in the world. We look at the past as for guidance, but don't be trapped there. You know, I continue to shake my head when I see poor performing valves, and yet the specification for them is still there to be purchased. You're trapped by an ancient specification. Let's move ahead. Lots of the inventions of valves that I see around the world, not just knife gates, are from the 1800s. The 1900s, wedge gates, they're an old plug valve, 2,000-year-old plug valves. So learn from the past, but don't live there permanently. You could still probably buy a black and white TV, but is it the right thing to do? I don't think so. So I appreciate the time. We've gone over it significantly. I apologize. But if anybody wants to hang on and ask questions, we're all happy.
We're not over time, Ross. I booked it for 2 hours. I just didn't tell you.
Oh, fantastic. Okay.
We take a look at the panelists, and we know that you guys are passionate about the subject. So,
okay, well, that's it from me. I appreciate the time.
Excellent. Well, thank you very much, you three. It's great. There's definitely some questions that have come in, so we'll continue rolling through those. So we touched on that one about the actuators. The follow-up question to that, and I think Kevin, you're starting to touch on that, are electric actuators becoming a more effective option for knife gates or DSS?
Can I jump into that one, because I'm the one who's had the most pain, I think. So here's the story that I'll tell you. The reliability of the electric actuator is without doubt fantastic. We're talking about the main brands, the Limitorques, the Rotorques, the Almas. All of those companies who make electric actuators were fundamentally totally reliable. They're wonderful. But here's the rub. When you have a rising stem valve or a non-rising stem valve, but it's linear, and you have to apply a rotary screw actuator to it, you've got to join the power output of the actuator to the stem somehow. And when you do that, you're going to have a stem nut. And with a valve design like ours, which is a guided shear gate, and it's designed so that it can close against things in its way, solids, whether they're fibers or scales or whatever else, you're setting up a force that is going to likely put stress on that stem nut. So where I am challenged is when it's poorly understood and the stem diameter is not made much bigger to share that load, and when the stem nut is not carefully selected, and that you carefully think about, do I stop turning the valve on limit or on torque? Which of those are the ones you're going to do? Because I've seen a lot of cases where the actuator continues to turn and break that connection. So the valve fails, but is it the valve's fault? Now, don't get me wrong, we do sell electrically operated DSS valves and in the past guided shear gates, but we're very careful to set them up properly and to make those decisions where we've got a much bigger stem than the normal stem. You know, our valve has a normal diameter, I don't know what it would be, Trent, but say 1 inch on a 12-inch valve, but 1 inch diameter. If it was electrically operated, I'd like to see that 2 or even 3 inches. And I'd like to also change from being a non-rising stem design to a rising stem design.
Yep. So we actually have done that, Ross, on our electric actuators above a certain size. Can't tell you off the top of my head what size it is, but we'll say 12-inch and larger. It may be a little bit different from that, but we have changed to rising stems in those situations for the exact reasons you described.
Yeah, but reality, all three are important in your arsenal. If you're out in the middle of the effluent pond, 10,000 feet away from the machine room, you probably don't want to run an airline out there all by itself or a hydraulic line out there. So that makes sense, and we can live with it. We just want to be careful that you don't underestimate the need to do it carefully.
Mm-hmm. Yeah, if you look at the picture actually on the slide there, you got two, I think, limit torques in the background on the DSS and one pneumatically actuated valve there. So definitely something we can option. Perfect. Yep. All right, thanks. Next question is, can you handle dry solids to class 6 shutoff?
Yes, absolutely, no problem. And by the way, can I go into this? It's another pet peeve of mine. So, and I apologize ahead of time for being this way, but it's an understanding. Class 6 comes from FCI 70.2. FCI 70.2, its title is allowable leakage rate, or it was, I think it's changed, but it was the allowable leakage rate for control valves. We are talking about isolation valves. And my mystery is, why don't we have an isolation valve standard of shutoff? We don't. It's being challenged, and MSS will eventually write it. They've agreed to do it. But having said that anyway, okay, if you want class 6, you test with 50 PSI air. That is the mechanism to prove, do you have class 6 or not? And based on the size of the valve, up to 12-inch only, you can figure it out up higher than that, but it's really only to 12-inch valves. You have a number of bubbles that's allowed to be counted to meet class 6. But then, so how does that affect isolating a dry powder? I don't think it's valid. So instead, what we'll say, look, we'll test the valve to API 598 or ISO 5208 rate A, or whichever one you want, to prove that we don't leak. And we can do that on powders. We can do that on liquids, clean liquids, whatever you want. So we're fighting a big fight. In hundreds of years, we've used this term class 6 or class 5 or class 4, but it's really not, in my opinion, the right one to use in the future.
We've actually gotten through some really good training on powders and bulk in the last 2 weeks here from one of our other manufacturers, and learned a lot that there's a lot of different characteristics based on the solids that are going through it. One of the nice features with the DSS is that we can install it in different orientations and different modifications to the design to be able to handle different types of solids. So if it's solid that is going to sinter or pack up, you may want to look at installing it in different orientation. There's body modifications that we can include in the chest to help make sure that media and solids aren't getting packed up in the chest area. But for sure we can supply a product that will give you the isolation required.
Yes, I guess a good point, Braden. There's purges we can put in there. We can also, because of the transfer seal, we can mount the valve in the upside down position. It's one that other types of knife gates don't like. It's really irrelevant to us, and there may be advantages. Again, a story from the past. One of our customers who was transporting raw ore feed to their plant 30 kilometers through a pipeline was transporting it through their screens with rocks the size of my hand. And he said, look, I want this valve to close and isolate the pipe if there's no flow. And so there could be a rock on the bottom of the waterway. So he said, okay, fine. We'll just put the valve upside down. As it closes up, the rock will fall off. It was a simple, elegant solution. So give us all the data and what you want, and we've got a solution one way or another.
Yeah, if you remember back 2 slides on that valve selection form, one of the questions that we like to ask is, what is your orientation? Because that will have some bearing on how the valve will operate.
So Ross, just to update for everybody, I went to the Fluid Controls Institute website, and the title of the document, FCI-2-2013, is control valve leakage.
Yeah, there's a statement in there that it's not to be applied to isolation valves, whose principal duty is isolation valves. So they recognize it, but it's just industry. It's been part of our fabric for so long. It's there, and it's hard to get rid of it. But just like using the word pound to refer to class, we need to stop doing that. it's not right. Class is class and pound is pound, and they shouldn't be used together. So I'd like all of us to make a promise. Stop using that little pound sign as a symbol or LB as a symbol when you're talking about class.
It's a hashtag now, Ross. You're outdated.
Sorry.
Social media for us here. All right, moving on. So do the valves work in both directions in situations with backflow, or would you use a different style knife? Great question.
Yep, absolutely, perfectly bidirectional equally. And this is a very another topic of generality. What does bidirectionality mean? And again, so I'll back up because I practice this a lot, talking about it. My car has a reverse gear. My car has forward gears. I can go backwards and forwards in my car. Does that make my car bidirectional? I would say it's bidirectional, but it's not equal. But the beautiful thing about DSS, it is equal, even though we have a preferred flow direction because the gate has a chamfer on one side, an edge, which we would like to see push objects to the downstream side. But when the valve is closed, because the seat is on the gate of the edge of the gate, it doesn't matter which direction the process pressure is coming from. It is truly bidirectional equally. So it's an important thing to understand because conventional knife gate valves are absolutely unidirectional and can be damaged and not work at all if they're put in the wrong way. And so again, look at a pump. If you're isolating a pump, suction and discharge, which direction are you actually isolating? A lot of times people don't consider what the duty of the valve is when it's in working mode and they put it in wrong. Well, you cannot put a DSS in wrong. You could put it in the lower preferred way, but it's still going to work perfectly.
I think it's important to mention too, with the DSS design, the guided shear gate, that's absolutely true, but it's absolutely not true for your conventional knife gates. They need that upstream pressure to push the gate into the downstream seat, and if you were to install it backwards, you would go from an allowable leakage rate to an extreme amount of leakage. So again, we got some good videos. So that is a differentiator between the guided shear gate design and some of the other conventional knife gates.
Yeah.
All right. Are wear rings primarily for high percentage solid slurries, or are they used for chemical corrosion resistance?
The first advantage in using the wear rings was for the mining industry, so for mineral slurries, tailings, or ore, and it was simply a way to produce a more inexpensive valve than having the whole body resistant to wear. So a wear ring was cut into the upstream side originally, and it made the flow move over the body. As we grew more and more sophisticated in mineral slurries, higher pressures, higher velocities, we realized that the number of cycles could affect the unprotected downstream side of the body. So we learned to put in upstream and downstream wear rings, and then we learned to put in weld overlays over the valve of the bore of the valve. But in the pulp and paper industry, the protection will come probably more often in recycle mills, where, as Kevin mentioned before, you're going to have metal staples, bands, glass, other solids that you want to protect. And so that might be where the abrasion gets severe. We need to understand what is damaging the valve. Is it erosion? Is it abrasion? Is it both? Is it corrosion? There's always a bunch of things. And as Kevin also mentioned, it's surprising that a soft material can damage a much harder material by flow, but that's what erosion is. It's flow based. It's not hardness based, whereas abrasion is all hardness based. By having the ability to hard coat with Rockwell C72 or harder materials, which are orders of magnitude harder than stellite, we can resist abrasion from just about anything other than some high diamonds or quartz or things like that.
Good. And sort of a follow-up question, or on the same sort of lines there, does DSS offer any deflector cone accessories to avoid seal seat damage for dry bulk slurries?
Absolutely, yeah. And some good lessons learned over the years on designing what that ID should be. How much of a deflection should you have? We've got a very good case study from Australia on an extremely weird application. Unfortunately, it's not pulp and paper, but I think it's very telling. It was radioactive tailings. And so the valve was a 16-inch class 300. It happened to be made of super duplex because it was acidic as well as radioactive. And we calculated that the flow rate would need a sort of a lift to get it over the seat. And so on that 16-inch valve, we came up with a 13.13-inch ID. We made it out of super duplex, we carbide coated it, and it's been in service for many, many years. So we can do a lot of special designs, and the manufacturing capability of DSS is wonderful. Over the years, they've learned how to do it from all types of base materials. Cast wear rings, machine wear rings, coated wear rings. So there isn't any hole we can't make. We can really design it exactly for your installation and make a very custom standard valve for any application.
Ross, do you mind just pushing your camera down a little bit? When you lean forward, we can't really see.
Okay, sorry, how's that?
Yeah, that looks good.
All right. Next question. In recycled paper operations, the issue of broken glass mixed up with collected recycled materials. The materials used in DSS offer longest service life. Any on-hand life cycle comparison versus conventional valves? I think you mentioned that in sort of the trash extraction and things like that.
Yes, in my experience, we've, in comparison to conventional life valves, whether it's Velan, Orbinox, Fibre, we've extended lifespans by anywhere from 6 to 8 times longer. The typical lifespan of valves that we replaced were 6 to 12 months. And while our guided shear gate is a premium, it was twice as much. Our valves would be lasting 4.5 to 6 years. Specifically, and we know that we can handle glass, we know that we can handle sand and staples. So I would expect in a recycled pulp mill, the exact same type of life advantage. And in fact, we've got some valves that are in thermomechanical pulp mills that are running for 12 years. But as Ross alluded to, you know, we need to know what the application is. Some producers will have, you know, the pH level might be low, it might be high. It'll determine whether we use an iResist or we use stainless steel, or we might use something else. So knowing what the application is and what the flush water conditions, chemical analysis of that flush water is, can help us in selecting the right materials and design for it.
Thanks. Good. Next question. Can you build a bonneted valve?
I guess the question is for what purpose?
Yeah, I'm not sure.
So if it relates to the world of pulp and paper, we're replacing bonneted knife gate valves because they just don't work long term. The stock does find its way, or media, whether it's a liquor service or it's a stock service, it finds its way into that bonnet, and that starts impacting the operation of the valve. So that was a design modification or add-on by conventional valve, knife gate valve manufacturers to improve the fugitive emissions or chest leakage by going to having a round seal on top of the stem. It's a band-aid. It doesn't address the true problem or the true symptom of the reason for the leakage. And what I've seen in these applications is that bonnet builds up with media and then you can't move the valve. So with the transverse seal and the DSS design, which is superior to every previous generation of guided shear gates, there's really no need for a bonneted knife gate valve in a pulp mill application.
Thanks, Thomas, for clarifying this. So it was more along the line of extra safety versus a bonnetless knife gate. So maybe I can take that, or Trent can fill in there. But with the external, the standard DSS knife gate comes with covers on the bonnet.
So we
And
do Lexan covers as standard, and then we do offer stainless steel metal covers as well. We do have some customers that want to be able to hose the area out, and so ultimately the idea is keeping fingers out because there are pinch points in there, and so for safety reasons we do protect it in that way. But it's not an enclosed bonnet, you know, in the sense of what Kevin was describing.
Right. Yes, and just another point on that, just to give some confidence. We in the year 2005, with a previous life that we all experienced at DSS and CG, we got an opportunity to put some valves on a very challenging application. Again, this is in mining, unfortunately, but they used H2S to precipitate nickel sulfide. It was the required chemical reaction to get what they wanted out of the solution. And H2S was in the pipe, and our valves were selected for it and have been in service since 2005 in this incredibly dangerous material without any issues, because the transverse seal design, that was generation 3 and then eventually 4 and now 5, it was so good. Putting it another way, we've got many applications in high cycle filters that will see an average of 70 cycles a day, and we go 2-3 years without having a leak to atmosphere. It is just a wonderful design that doesn't do why, like the early days of the bonneted valves came out of companies like Fibre and Rovalve, that they had a problem. It was really challenging to have a conventional knife gate valve and not make it leak to atmosphere. So that it was necessary for them to do that to protect. But in our design, it isn't necessary because we've got one that doesn't leak.
Dave mentioned, Dave Friesen mentioned as well that we have for some applications where it's also trying to protect from the environment back into the bonnet. We've done sealed bonnets where we can seal the top works, and actually in some cases we've put a 5 psi air purge just to give us some positive pressure inside the bonnet. So definitely things we can do. The top structure of the DSS is like the valve itself, has been engineered, designed for a lot of purposes, and being as robust as it is, we can definitely make some modifications to it to meet the application needs.
Yep, good point.
All right. For slurry application, what is the limit of percent solid concentration that the KGV will work?
None. First of all, I may be a bit facetious there. We just gave a talk the other day, a presentation on mining slurries. So the definition of slurry is a little bit gray. We decided through industry that it's 10% solids or higher, and anything below that is just dirty process. So in that sense, a slurry is a liquid carrier, usually water, with a solid, usually in suspension. It could also, though, include dissolved solids or a combination of both. And the typical concentrations we see in industry where this is used are up to 70% solids in the water solution. If you're talking about just straight solids without like air pneumatically conveyed, we can take whatever can be packed into the pipe. I mean, obviously it's not going to be 100% because you got voids, you got air, you got something moving around. But really, we're not worried about the percentage of solids. What we want to know is what size are they? What hardness are they? What are they made of? What percentage are they? Do they stick or do they just fall off? Those are the kind of things that will give us the idea what we're going to put the valve together as far as its gate material. We have everything from the basic is 316. Well, 316 in a slurry is soft. It should probably not be used. But then we go to 17.4 pH, and we're using a condition 900, which is a through heat treatment. So that's a Rockwell C44, which is 2 points harder than stellite. That's a pretty hard gate material. And if that's not enough, then we can put on the carbides, the chrome and tungsten carbide, to get it up orders of magnitude harder, again, with the wear rings and everything else. So the solids, we're very comfortable with high degrees of solids. But practically, I don't know, I have never seen a slurry in my eyes in pulp and paper or mining that would be above 74% solids.
Yeah, Kevin, maybe I'll speak a little bit to the black liquors and the heavy blacks that can be a problem for some valves. And where we've used DSS?
Certainly. You know, in the green and white liquor and unclarified states, we will see you know, the solids precipitating out and creating a scale. With the wedge and screw design of the DSS guided shear gate valve, we're able to overcome that. And when it comes to varying wood species, will create different levels of scale. So not only should we know what we're dealing with in terms of the liquor service, but are they processing a hardwood or are they processing a softwood? Hardwoods tend to create a thicker scale layer that we discovered at the Hinton Pulp Mill in Hinton, Alberta, whereas the softwoods don't produce as significant amount of scaling thickness over the same defined period of time. And that's you know, a little nuance of the pulper industry that we don't always think about, but once you've seen it, you learn about it, and it's something to be considered. But in the heavy black liquors, that's where we started first using guided shear gate valves, and they are very successful. Again, the full guided gate, the wedge and screw design, we can overcome those solids conditions. One thing that I will note about green liquor services or white liquor services, we do have an operating procedure that you may not be able to get the valve fully closed on the first cycle. So you can back it off, allow the valve to flush, and then repeat. So as you're breaking up that scale, as long as we got flow, it's going to continue to move downstream, and that's one of the one way of overcoming the issues that could be occurring in a scaling application. But we've used it on high density pulp, anywhere from 18 to 22% stock solids percentage. And we've never encountered pulp stock application issues. It's the recost area that presents a few more challenges, but we can prepare the valve as required with oversized hand wheels, with bevel gear operators. As Ross showed earlier in the slide for mining, we can go to larger diameter or larger bore pneumatic cylinders to account for those increases of thrust force generated by scaling or thick slurries.
I think that's a good place to also talk about that, you know, different jurisdictions in Canada and the US have a limit on the amount of human energy that should be applied. And really it's been pushed back on the suppliers and manufacturers to determine that they don't put out a valve that needs energy higher than a certain safe limit, which I think is 80 pounds of rim pull, or it used to be. And I think right now it's being challenged to even be less. So that has to do with how much energy at waste level, by the way. So if it's not at waste level, you're even reducing it further on. So how big a hand wheel is practical? I think there's a limitation. And if you don't have a hand wheel, then you go to a gear. And if you can't do a gear, then you do with an actuator. Years ago, I was amused to find out that many places in Australia have manual valves that got pneumatic cylinders on them and little joysticks. And the manual valve operator was the guy who went up to the joystick and moved it up and down to make the pneumatic energy in the actuator do the muscle work that he used to do. That is his manual valve. So in liquor, like Kevin said, sometimes you may not be able to get it closed on the first stroke, depending on which actuator or operator you had on there, but you can do it a bit at a time, chip it on, chip it, open it, close it, and do it. There's many strategies. But if the mill says, no, I want it closed on one stroke, well, then we go back to that picture that we showed you and put a 22-inch bore cylinder on a 10-inch valve. It will do it.
All right, we got 7 more questions here and some more coming in. So do all valves meet American Iron and Steel AIS requirements as standard off the shelf, or does AIS have to be specifically requested?
Yes, we do meet that requirement. The requirement is that the body and the gate are manufactured in the United States, and that is true.
100% true. Perfect. Have you used DSS for digester blow? How about with blow valve services using a positioner?
We've not, on the blow line, we have not used a guided shear gate valve with a positioner. It's absolutely possible. We have used the guided shear gates on blow valves or on blow lines and blow tank applications for 10 years now at least. So it's definitely an application that we can where we can provide the guided shear gate design.
Yeah, and just further to that, Trent has at DSS has been using a limited number of cylinder providers, and the one that is being used the most has been working for quite a few years on getting what they call an intelligent cylinder. So they machine a sensor into the rod, and that sensor can communicate either by wire or by Bluetooth to a positioner that can be remotely mounted. In Vancouver, we have a flow loop, and we put one in on test so that we could see how it works. And it was really a great benefit to be able to put a valve and cylinder on a very high vibration area and have the positioner safe 30, 50, 60 feet away, communicating, telling the valve how to move. Now, in this case, we weren't trying to throttle it. I mean, we could, but what we did is what we wanted to do was have end of travel command and have infinite speed adjustment. That's what was eventually done. But really, you want a throttling valve with a positioner on or off the valve, we can do that with the way that DSS has partnered with the cylinder manufacturer.
And an advantage to that internal transducer for position communication is for just an application like the blow line where there is vibration present, eliminating all those mechanical connections between a clevis or the rod itself to the positioner are eliminated with using an internal sensor inside the pneumatic cylinder. Not to mention, there's no pinch points. There's no components that are going to collect pulp stock if it gets sprayed on. So.
And sprayed on by other manufacturers, not by DSS.
Exactly.
Tank overflows.
All right. Any advice on getting a customer to switch from MOGAS? Not a high temperature application. Customer has had bad experience trying other valves.
Well, okay.
Curious about the application, but.
Yeah.
MOGAS makes metal-seated ball valves. They're one of the premier manufacturers in the world, no question. They're a very robust design, metal-seated ball valve. Their particular design is a very small floating ball valve. Their seats are often locked in. They're more famously known in the mining industry and some in applications. We know them pretty well. I would go up against them quite happily, because my advantage, or our advantage, DSS's advantage, is that the cost to buy a DSS size per size and class per class is fundamentally lower. We can be a third, a fifth, a sixth, and then on top of that, the repair cost is going to be a fraction of what it costs to repair a metal-seated ball valve. And yeah, but will we outlast a MOGAS depending on the application? We may not be with 100% exactly the same, but we'll be very close. And so from a cost of ownership, I think we'd be 100 years to disprove that we wouldn't be the right the valve. So bring it on.
All right. So next one is, are the transfer seals similar to those used in the Way design or other manufacturers' designs?
Yeah. If we jump back to slide 55, we have a comparison of that. Yeah.
Just past it.
That was it.
More. Keep going. One more. Two more.
Three more.
You guys have, well, yeah, there.
There it is. Back one.
Sorry, got too many tabs open here.
There
you go.
Okay. Yep. So what you see is Gen 2 there on the left. That is the Way seal. So you can see it's got one scraper on the left, and it's got a very thin cross section. Gen 3 and 4 made some improvements to that, added two scrapers, one on the left, one on the right. Still had the thin cross section, and then DSS is quite a bit different as seen on the right. bigger scrapers, thicker cross section, but still similar. So, you know, Way goes back to generation 2 and we're at Gen 5. So a lot of improvements over Way.
I think it's important to understand too that the Way, which their parent company, in transparency, was the patenter of this type of valve back in 1960. So they were the first off the block. But their black, if you look at that generation 2 seal carefully, it's a double V. That doesn't, on the bottom where it attaches to the gate, it's not one piece, it's two pieces. It's joined in the middle. And they actually use a little bit of tape to hold the pieces together. And when you open and close that valve, that it can be scraped away, which then allows the hydraulic loading stuff, the green packing, to come out, and they lose the seal. And again, their standard is one transverse seal per valve, as is the generation 3 and 4, whereas DSS decided, you know what, let's do 2 transverse seals in all our valve sizes above 3 inches.
4 inches.
Above 4 inches, okay.
I think one of the things, so to mention with this design compared to other packing designs within knife gates is that it's a vast improvement over the conventional knife gate valve packing. The transverse seal allows for repacking under full line pressure while the valve is actuating. That's what those 2 little screws are on the side of the valve body there, and so it's a great improvement on that conventional knife gate valve, and the DSS design is again a further superior design to others. All right, a couple more here, guys. Thanks for hanging out. Do you have experience in the application for particle board and plywood processors other than just pulp and paper?
So we do for James Hardy cement board. So a little bit different application than plywood and particle board. I don't know if Kevin, Ross, you guys know of any in Canada in that?
We used to have a bit of a plywood industry. It's gone. And so in the early days when we had it, I think it was in the 80s and 90s, we did play there. There wasn't as many applications for our technology in those days in this business, but any of the fiber, when the glue, the resin, I think we could be successfully used there, but it has disappeared.
Yeah, it's there used to be, I think, 6, maybe 7 in northern British Columbia that we're down to 1 or 2, and they're not looking. The future isn't bright for them. But yeah, it's where we've had discussions around it. It's been around the resins. A lot of chipboard is typically conveyed, but there wouldn't be a reason in my mind that we wouldn't be able to utilize the guided shear gate in those industries.
In the very few processes that would require, a pipe and a fluid moving down it.
Yeah, agreed.
It's more of a, it's an open process with presses.
Yeah.
How does DSS handle cementing slurries, or I guess, or other solids with the full length gate guidance? So
I mean, really, the unclarified white liquor or green liquor, lime mud could be considered a cementing process. Again, the wedge and screw design, the full gate guide prevents the blade from deflecting as it encounters those solids. And the tip of the blade is shaped like a chisel. So it's designed to chip away and discharge the media as it travels into the closed position. And if you notice, we have at the corners at the 5 and 7 o'clock position, we have flush ports. So it's another discharge area to remove any type of solids that may have collected inside the gate guide or adhered to the idea of the valve bore. But again, knowing what forces and what energy are required, utilizing bevel gears or oversized hand wheels or pneumatic actuators gives us that energy required. The top structure is robust. It's extremely strong. so that the energy that is being generated at the hand wheel is going into the blade and attacking any of the cementing that has occurred inside the valve.
Right. One other thing that we've learned over the years is that scaling is, so far, no one's figured out how to prevent it from happening. But what we've been able to do is handle it when it happens more effectively by using surfaces that we coat. So when we're in a scaling application, the body and the gate are offered with two non-stick surfaces. Xylan, which is a polyamide and PTFE baked on coating, which goes onto the body and the gate, prevents scale from having a very tough grip. And then there's another even more superior chemical anti-stick surface with using FEP Teflon that is baked on as well. So we've got two ways we can treat the inside of the valve that will help lessen the grip that the scale is going to have than if we didn't coat it. You know, the scales like to find the minute little holes to anchor into. Well, if you put those holes, if you look microscopically in our gate, even if it's well polished, which DSS is, there's still going to be tiny little holes and valleys and hills that can attract scale to anchor. But if they're filled with the Teflon or FEP, then they don't have a place to get there, and it's easy. It's your Teflon frying pan idea.
Mm-hmm. Yeah, it's a really good point about the pores, because they are filled. Even if the surface coating does wear as the valve's in service, those pores are still filled with that FAP or Xylan coating.
Yep, it's impregnated into it.
All right, a couple more here, guys. Through gate valves are used for stock diversion and are considered a man-safe line blind. Has DSS been used for stock diversion out of the HD stock chest? What is the question?
Yes, they have. In our case, man-safe was not required, but we have a fully supported blade, and through our WorkSafe Association, they've accepted that it would be a man-safe design or similar to a line blind. It's truly not going to meet the line blind, because with a line blind, you need to be able to discharge pressure. So through our CBB or DBB, double blade and body valve, we can have a discharge area, and through the particular safety association, seek approval, for our case in British Columbia anyways. Yes, we have used it on high density stock transfer.
Yeah, it's a good point. The center block and bleed, or the double gate with an interior that can be drained and purged and proved to be holding pressure, or you can fill it with a inert object at higher pressure, like nitrogen or some kind of paste. So it's a very good extra safety. We use it again in a lot of different industries. For example, in mining, in sulfuric acid of various strengths. Very popular in Australia for the nickel business, where you're using sulfuric acid. And it's a very quick way of proving, have I got isolation? You close the valve, it's got a single operator, whether it's manual or automated. You lock it, closed position, you open the drains, you put on the purge, and now you know that if nothing's going past the upstream seat, and you're able to work downstream very safely. This was developed in a lot of applications in big valves, up to 40-inch, to get large vessels able to be reached in a very quick time.
Okay. The follow-up question, I think, why do you consider man safe? So I'm sorry, I forgot the last question.
Yeah.
You know what, Kev, you know that one referred to?
Man safe is really so that you can work behind it. You know, if we look at hydroelectric facilities where their pen stocks are 144 inches or 200 inches, they need to be able to walk inside the piping system. That's my term definition of man safe, is being able to work downstream of that valve. And that is one of the areas, because our valve is fully guided, it does not get deflected by pressure. we're always in contact with the seat, and we can provide zero leakage. It allows people to work downstream of those valves, or in the case of a pump discharge application, upstream of that valve. It's going to hold back any of the downstream media that may come back to the pump. But that has been our greatest success in our pulp and paper industry in Western Canada, is the ability to have a true knife gate valve that actually cuts through solids and seals, and doesn't require any pressure to seal. And it has provided a great number of hours of efficiency to our mills in Western Canada.
Yeah, I think just to add that though, that the question on the man safety, it is, as Kevin mentioned, it's a jurisdictional definition. Every province in Canada, every state in the US may have their own definition of what that means. And I think it can go back as far as confined space entries. All these things, these terms need to be examined within the jurisdiction that you're in. There isn't a single agreed definition for every place in North America. They're all fairly unique. And if I was to suggest, or Kevin would suggest, that you could use a DSS for a specific man safe requirement, wouldn't be the case. But if we put in a double block and bleed, then we've got a different animal that may be. But you'd have to go to your safety department, OSHA, whoever it might be.
Okay, we've come up to 11 o'clock. One quick question: are Gen 3 and 4 seals still being used? The answer is not in the DSS design, but in other manufacturers are still using those, as is this Gen 2 design. But DSS has standardized on their upgrade to the transverse seal, and it's the dual transverse seal throughout a standard above 4 inch and above. Right, and last one is this: what percentage of shear gate type valves are used in the market for total knife gate slurry valves?
It's a good question. Certainly growing. The mystery to me, well, not really mystery, but a valve that was designed in 1960 is still unknown in most of the world. The guided shear gate term is a fairly new one that we just decided we had to invent so that people would differentiate it from other knife gate valves. The success of it and the ability to go into these higher pressure classes is really making it the fastest growing design anywhere. And my own company, our CGIS, we've sold more than 30,000 of them right now, and it's growing. Our success rate is higher and higher. We do not sell, and we haven't sold since 1980, any other style of knife gate valve. We, at one point in our lifetime, we were generation 2-ish, and then we lost track of that company. We thought they went bankrupt, and we picked up Fibre for, I don't know, 10 years or so, until we rediscovered the company that we thought had gone bankrupt, which was an area that, or a company that Trent started working for and has that history with, and that's how we know each other for so long. But I don't have a true definition of how many knife gate valves are sold and what portion are GSGs. I would suggest, if I'm going to guess, it's probably at least globally 30% in or higher now, and will continue to grow. And I think we'll put the conventional knife gate valves away. They may still be used in Asia, where they don't appreciate performance as much as we do out here. Labor's cheaper. They can afford to have crappy valves. I wouldn't have it in my place that I owned.
Perfect. Well, that is all the questions. Just on 2 hours there, so I really appreciate everybody that stuck around. We will be sharing a couple, we'll be sending out an email with links to the presentation and answers to any other questions. If there are any other questions that come in after or have any other thoughts, please feel free to reach out to 3 panelists, myself or Sam. Happy to answer any more questions for you, and have a great good weekend, and keep safe.
Absolutely. Thanks, guys.
Yeah.
Thanks all.
Great. Thank you very much, everyone.